So we were here and we said that we have 5 components in a communication system: the message, the sender, receiver, medium, and protocol. So it's clear for you what's a message. Message is my voice is a message now. When I send you something like text, that's a message. Numbers, pictures, video, audio, whatever, this all message. Okay, so the message is the the part that makes you want to communicate. You have some message you want to communicate. If there is no message, there is no need for communication. Okay.
دكتور تشير نكريا
Sorry. Okay. تركب وانا. Okay, so as we said, the message is the most important part of communication system, and thus the key that you want communication to take place at first. So if you don't have message, there is no need for communication. So the next component is a medium, or as we have sender, receiver, medium. As we said, medium can be a coaxial cable, wireless medium, like when you use Wi-Fi, for example, you need wireless, or it can be copper cable. We'll use, for example, Ethernet cables. We'll study them, or it can be a fiber cable. So this is fiber, this is copper, this is coaxial cable, this is wireless medium. So we have different types of media, and we need to have some sort of media. Actually, wireless, when you say wireless, can occur without media. It's clear. If you have two wireless links, they can communicate even in free space. So you don't need actually media, but we call it wireless media or medium. Data flow modes. أفاد بيشتن 10 دقيقة دي روستن دي عندك شوية لوك كربو على كل إنك روستاز دي ريستارت كما فجرك دي عندي شو الكات بس فد رجع حتى يعني paid account كي use كان باش okay. So the data flow modes, we have actually different types of data flow modes. What we mean by data flow mode, how the data moves. So this is the sender, this is the receiver. In this case, for example, the data flow from this side to this side. This is called simplex mode. So it's only sending. It's like when you watch TV. You just receive the signal from the broadcast channel, broadcast station. There is no way for you to communicate back with the station. Like monitor, you connect your monitor to your computer case via cable. So the data will go from the case, the computer, to the monitor, not other way. Although there is nowadays monitors, there is some sort of communication actually. So this is the simplex mode. simplex means one direction. We have half duplex. You see half duplex, you have two stations. This station can send to this station, and this station also can send to this station, but they should do one operation at a time. They cannot, this station 1 for example, cannot send and receive at the same time. It either sends or receives. The same holds for this station. This is like walkie-talkie. So when you have walkie-talkie, you can send or receive, but not both at the same time. So you press the button to send, to talk, and the other one will receive, or the other one presses the button to talk and you will listen. So this is called half duplex. You can send and you can receive, but one operation at a time. And we have the full duplex. So full duplex is the you can send and receive at the same time. For example, now our channel, our communication channel, me and you, we are using, we can say, full duplex, because I can talk and you can also hear me and you can talk at the same time. So these are the main three types of data flow mode: simplex, half duplex, and full duplex. So now we go to the question, what is a network? So a network is actually an interconnection of set of devices. We have a set of devices. These can be different devices. They may not also all be computers. Different devices capable of communication. In this definition, a device can be a host such as large computer, desktop, laptop, workstation, phone, printer, or a connecting device. So a router is also a device, a switch, a modem. So these are all network devices. They connect to each other to make a network. These devices in a network are connected using, as we said, media. Media can be wired or wireless transmission media, such as cable or air. Of course, as we said, wireless does not need media. We can say free space also is. So it doesn't need a media. So we need network devices, and we need connecting devices, and we need media to connect these devices to make a network. So what is a network? Devices, connection devices, connecting devices, and media to connect these devices or all together to construct a network. We have two types of connection: point-to-point connection, okay, so station to station, and there is only single link between them. This is called point-to-point. And we have multi-point connection. You see here, this cable, this link connects multi-devices, not only two devices as here. So this is called multi-point connection. This is point-to-point connection. One second. بوعدي تركيبة المؤشر.
لا دكتور درنا كيف
درنا كيف لازم كمان بين or laser point. Now تركيبي pointer.
بارد.
تمام. اوكي. So we have either point to point, which means we have two devices and there is a link between them, single link, and we have multi-point connection. There are many devices connected by this link. This is called multi-point connection. Now we talk about the physical topologies. This is very easy topic and it's also important. So when we say physical, means how physically connect them. We have actually physical topologies and logical topologies. Now we are talking about physical topologies. This session will end in 2 minutes, but we'll immediately start, okay? No breaks. So we have the mesh topology, the star topology, the bus topology, and the ring topology. Easy. So mesh topology, we have stations, and each station has got a connection to all other stations, its own dedicated link, okay? So station, if called station 1, has a connection to station 2, another connection to station 3, another to 4, another to 5. The same for station 2. It has a connection to all other stations. So each of these topologies has its own advantage and disadvantage. So in this case, if you have n nodes, how many links you need? Now in this case we have 5 nodes, okay? So how many links in there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And true? So we need 9 links. And the equation is n, the number of nodes, times n minus 1. Is 5 times 4 equals 5 times 4. So 5 times 4. So now how many connections we have? How many stations? 5. 5 times 4 divided by 2, which is 10. So we have to have 10 links. Let's count them. 1 link, 2 link, 3, 4, 5. بزحمة ميوت كان أيدي تخو. and now these links 1, 2, 3, 4 and 5. So we have 10 links. If you have 6 nodes, so it will be 6 times 5, 30 divided by 2, 15. So you need 15 duplex links to connect 6 devices. You see the number increases when the number of nodes increase. So this the advantage here, dedicated links eliminate the traffic problem. Links are shared by multiple devices. So if there is high traffic, there are dedicated links. So if there is high traffic here, it will not affect this link because there is separate link for this. In this case, advantage is robustness. For example, if this link is broken, the whole network is not disconnected. All other devices, this card communicate with other devices, and it can even connect with this device through another channel if the protocol allows. So it's more robust. And privacy and security, because you have dedicated links. So station to station is through a dedicated link. So if you communicate with this station, the other stations, you can make them not able to listen to your communication. And you have point-to-point links. You see, these stations communicate through or via a point-to-point link. These ones or this one, so they communicate via point-to-point links. And this makes fault identification or isolation easy, because if there's no communication between these two stations, you'll inspect this link. You see what's the problem with this link. If there's no communication between this and this, you'll check this link. If there is no communication between these two stations, you'll check this link. So it's easy to identify the problem. But there are disadvantages actually with this topology, which include the difficult installation and reconnection, because you need all these links. The sheer bulk of wiring can be greater than the available space in wall, ceiling, or floor can accommodate. So for example, if you have 20 computers, 20 devices in a building, and you want to communicate this using this topology, there will be very large number of cables. So each device will need how many links? Each device. In this case, we have 5 links. So how many ports we need or links in each device? n-1 ports. So in this case, 5 minus 1, 4 ports. But if you have 20 devices, then we need 19 ports on each device. And how many cables? How many links? 20 times 19 divided by 2. So it's say 190 links you need. Okay, that's a very large amount. And if you put these all cables in a trunk, it will be huge. So this actually may be not practical topology in all scenarios. So some networks use this topology when you need these advantages, for example, robustness or privacy, you may use this topology, but nowadays is very limited in use. The hardware required, because as we said, if you have 20 devices, then each device will need 19 ports, 19 Ethernet ports, for example. That's a big number, and that will make it much more expensive. Okay, so you have to consider the advantage and disadvantage when designing your network topology. Now the other topology is the star topology. It's simple. So you have central point like a star, and then the rays. The devices connect this central. This central point can be a switch or a hub. This is a very simple topology. It's less expensive than mesh. One link and one input output port for each device. So this needs one link and one input output port. You know what we mean by input output port, right? What's an input output port on your computer, for example?
سيدا مثلا جهة فلاشة وجهة إيثرنت صح؟
يعني Ethernet مثلا أو port. For example, if you are using wireless, you have a wireless LAN device. That's the port that you communicate with. So if you have one link, in this case you need one port or one wireless card. But if it was this, you need on each device 4 wireless or 4 Ethernet ports. Okay, that's expensive. If you have instead of one, you need to have 4. So it's less expensive, this one. It's easy to install, of course, easier than the other one, and less cabling. You see, in the other one, for 5 devices, we need how many? You said 10. For 5 devices, you need 5. But when the number increases to 20, we needed 190. Here we'll have only 20. So it's exponential on the other side, because it's power 2. You see here, n times n, which is exponential. So when the number of nodes increases, here is linear. Whatever the number of nodes, the same number of links. Okay, so it's less expensive, less cabling needed, and it's robust, because if some link is broken, the others will work. Okay, so it's still there is some sort of robustness, but there are disadvantages here. If this central point is broken, then the whole network will stop. So this one is a single point of failure. Okay, but if this device fails, it's fine, all the other ones will work. It actually needs more cabling than bus topology that we'll study later in this slides. Well, the other topology is bus topology. You see, there is a connecting bus. We have cable ends, terminators. This is a station, this is another station. They all connect to the same bus. This is multi-point topology, as we said. You see, all of them are connecting to the same bus. The advantage here is simple, easy installation, because actually it's not very easy, but it's easy to install, and you need less cables here. You see, here we needed 4 links. Here we need, this is the main bus, and these are short connections. This is like, for example, at cable TV uses this. Cable TV, there is a cable from the company that goes like a bus through the city, and at your home you connect to this bus. So you need short link to the bus. You need tabs. These are called T-tabs. We connect to the bus. So another subscriber will connect to the bus. Another one will connect. These are short links. This is the main cable that goes through the city. So in this case, you need less cables than a star topology, because if you wanted to do this cable TV, for example, via a city, if it's a star, then all these stations should go to the main to the TV station, a TV channel, dedicated link. So there will be more cable needed. So, for example, make 1 kilometer or whatever distance it is. But there are disadvantages actually: difficult reconnection and fault isolation. Why? Because when you connect a new device, you have to cut the cable here, for example, put a tab, then when you cut, all the other stations may stop. Okay, even if the feeding is in this side, they may stop because the termination is not proper. So when you install new connections, it's not easy. If there is a fault, for example, if this tab is broken or something wrong with it, maybe the whole network will stop. So it's hard to isolate faults. Adding new devices requires modification of backbone, because when you add new device, you have to create a tab here and then add. So it will affect all the other stations. Fault or break stops all transmission. The damaged area reflects signal, because this is like transmission line. You studied transmission lines. If it's open or it's short, there will be reflections that will affect the communication process. The other topology is a ring topology. From the name, we have ring, okay, and we have the stations connect to this ring. Each device has dedicated point-to-point connection with only the two devices on their either sides. And this station has a connection to this and has a connection to this. This one has a connection link to this one and another to this. So a signal is passed along. Actually, here is we call it ring, along the ring in one direction. So if you want to send the signal, you have either to go this way or this way, but always that. So if the direction of transmission is this way, so you send to this station. This station can send to this station, and so on. We'll talk about the logical topology later when we talk about token ring and token passing. So the direction of transmission would be in one direction. Each device incorporates a repeater. So you need, because this one, for example, can be a fiber cable, so you may need a repeater here. The advantage of ring topology: easy to install and reconfigure. Connect it may not be that easy actually. Connect to immediate neighbors and move two connections for any moving. Fault isolation is simple also, because you see there are dedicated links, and if any link is broken, then the whole network will stop. Fault isolation, as we said, is simple. The disadvantage is unidirectional. As we said, the communication goes in one direction. If there is one broken device or link, the whole if any of these links is broken, the whole network will stop. Or if any of these devices is broken, it cannot handle that token, it may also, or repeaters is broken, it may stop the network as a whole. Actually, some of these disadvantages can be solved using hybrid or dual ring topology. Dual ring is, instead of one single ring, we have two rings. Okay, so it's main ring and backup, you can say, ring. We have also the hybrid topology, which is the most widely used topology. So in this case, you have different topologies in a network. So in this case, we have, this is what topology? You can tell me, what is this topology? This one only?
Star.
This one? No, only this part. What is this topology? You see,
Bus.
it's bus topology, okay? This one is bus. This one is another bus. So 3 bus topologies. Now, if you think of this, central and links, so this is a what? Star topology. So bus is star topology to construct a hybrid topology. Okay, so hybrid topology, we have bus and we can, of course, can be any. In this case is bus and star. You can have ring, bus, star, all types of topologies. Okay, please send me or write in the chat your names, and we'll end this. Hour. نافخ بزحمة, in 1 minute send your names in the chat. We'll continue